My name is Christoph Yao Gadese. I hold MPhils in mathematics education. I'm taking you through Math 101, Algebra and Trigonometry. We are on Unit 4, Polynomial Functions and Linear Programming. We will start with Section 2, which is on quadratic function. Let's look at the objectives for Section 2. By the end of this section, you should be able to A. Distinguish between a quadratic function and a quadratic equation. B. Solve quadratic equations. C. Draw the graph of a quadratic function. And D. Identify types of quadratic roots. Let's talk about quadratic function and quadratic equation. In a polynomial function, the highest exponent of x is called the degree of the function. So if you have a polynomial of degree 2, then that polynomial is a quadratic function. For example, if you have f of x is equal to ax squared plus bx plus c, this is a polynomial function that has degree 2 and so can be called quadratic function, where a, b, and c are real numbers. However, a cannot be equal to 0 because the moment a becomes 0, the whole function will be reduced to linear function. But b and c can be 0. And so if b and c are 0, then you have a quadratic function of only one term. Now, if you equate f of x to 0, then the whole expression will now read ax squared plus bx plus c is equal to 0. In that case, it is no longer a function, but an equation. And so that becomes a quadratic equation. And the quadratic equation can be solved for the values of x. Example, solve the following equations. 1. X squared minus 6x plus 5 is equal to 0. B. 2x squared minus x minus 3 is equal to 0. And C. 6x squared minus 17x plus 5 is equal to 0. If you look at these three examples, the first one has the quadratic term x squared that has a coefficient of 1. Then the second one, the quadratic term x squared has a coefficient of 2. And then the third one, the quadratic term, has a coefficient of 6. We'll look at how to solve these questions at the next stage. Let's find a solution to the questions. And let's consider the first question, where we have x squared minus 6x plus 5 is equal to 0. To solve this, the first thing you do is to look at the coefficients of the quadratic term x squared. In this case, the coefficient is 1. So whatever the coefficient is, you use it to multiply the constant term. In this case, the constant term is 5. So we do 1 times 5, and we get 5. We then look for two numbers that if we multiply, we will get 5. But when we add, we get the middle term, negative 6. Now, there are different pair of factors that you can use. You can use 5, 1. You can also use negative 1, 5. Now, if you use 1 and 5, we see that 1 times 5 is 5, which is true. But 1 plus 5 is 6. But the middle term is negative 6. So we can't use 1 and 5. Let's go to negative 1 and 5. Negative 1 times 5 will give you negative 5. But what we are considering is positive 5, not negative 5. Then let's look at another where we have negative 1 and negative 5. Negative 1 times negative 5 will give you positive 5. Negative 1 plus negative 5 will give you negative 6. So this means that the two numbers that we will consider are negative 1 and negative 5. So we will use these two numbers to replace the middle term with a variable attached to them. So the equation x squared minus 6x plus 5 is equal to 0 becomes x squared minus x minus 5x plus 5 is equal to 0. Then the first two terms are put into parentheses, and then the last two terms are also put into parentheses. Now, when you are putting the last two terms into parentheses, because of the negative that comes before the parentheses, the sign in the bracket must change. That is how come in the bracket you have 5x minus 5. Then you look for the common term for the first two numbers. The first two numbers, x is common, so you bring it out. So in the bracket, you'll be left with x minus 1. Then when you get to the next two, 5 is common. You bring 5 out. In the bracket, you have x minus 1 is equal to 0. Then we are going to factor the common factor out again. The common factor here is x minus 1. So we bring it out. And then we are left with x minus 5 in the bracket is equal to 0. Since x minus 5 into bracket times x minus 1 into bracket is equal to 0, it means that it's either x minus 1 that is equal to 0 or x minus 5 is the one that is equal to 0. So you simplify and you get your x to be 1 or x to be 5. Let's consider the second example. Over here, the coefficient of the x squared term is 2. The constant term is negative 3. So when we multiply 2 by negative 3, we will get negative 6. Let's now look for two numbers that when we multiply, we'll get negative 6. But when we add, we'll get the middle term, which is negative 1. And so we will consider negative 3 and positive 2. And so we use these two numbers to replace the middle number with the variables attached. So we will have 2x squared minus 3x plus 2x minus 3 is equal to 0. Then we put the first two into parentheses and the last two also into parentheses. Over here, the sign that comes before the last two in parentheses is plus, and so the sign in the bracket remains the same. Now, we realize that 2x minus 3 is again common, so we factor it out, and then we are left with x plus 1. So it's either 2x minus 3 that is 0 or x plus 1 that is equal to 0. And so when we simplify, we get x to be 3 out of 2 or x to be negative 1. I would like you to try the third one before we get there so that you can compare your answer to what we will get. Okay, so here is the solution to the third one. I hope you have gotten it right. The coefficient of the quadratic term x squared is 6. So we will use 6 to multiply the constant term 5 and we get 30. So we get two numbers. Now if we multiply, we get positive 30 but if you add, we get negative 17. So the two numbers are negative 2 and negative 15. So we will use them to replace the middle term. So the equation becomes 6x squared minus 2x minus 15x plus 5 is equal to 0. The first two in brackets and then minus the last two in brackets. And as usual, the sign before the bracket for the last two is negative. So the sign should change in the bracket. Then when you consider the first one, 2x is common. So you bring 2x out, then into bracket 3x minus 1. Then plus the last two, 5 is common. We bring 5 out. We have 3x minus 1 in the bracket. So again, we see that 3x minus 1 is common. So we factor it out. And the other bracket becomes 2x plus 5. So it's either 3x minus 1 is equal to 0 or 2x plus 5 is equal to 0. So x is equal to 1 out of 3 or x is equal to negative 5 out of 2 when you simplify. I guess your answer is the same as what we have here. We have come to perfect squares, and perfect squares are mostly in the form bracket opened a plus or minus b bracket closed squared is equal to a squared plus or minus 2ab plus b squared. These expressions behave in a certain way. Study the four examples and see if you can deduce any behavior about them. If you studied them well, you will notice that if you take the middle term, you find half of it, and you square the answer, it will give you the constant term. For example, if you take 8, half of 8 will give you 4. 4 squared will give you 16. Or if you take negative 8, half of negative 8 will give you negative 4. Negative 4 squared will give you 16. Second one, if you take the middle term, the coefficient there is 4. Half of 4 is 2. 2 squared gives you 4, which is the constant term. Then if you take the third one, the middle term, negative 2a, the coefficient there is negative 2. Half of it will give you negative 1. If you find square root of negative 1, if you find the square of negative 1, you get 1. The fourth one, the middle term is 6z. So if you take the coefficient 6, half of it will be 3. If you square the 3, you get 9. So mostly, if you simplify these expressions by way of factorization, it gives you repeated factors. So t squared minus 8t plus 16 will give you a repeated factor, t minus 4 twice. Y squared plus 4y plus 4 will give you y plus 2 twice. And then z squared plus 6z plus 9 will give you z plus 3 twice. We looked at how to solve quadratic equations using method of factorization. We will continue to solve quadratic equations using another method we call method of completing the square. Now let's take an example to illustrate this method. The first one, x squared plus 8x plus 6 is equal to 0. We realize that this question has the quadratic term, which is x squared. It has the middle term, which is 8x. And it has the constant term, which is 6, and that is equal to 0. So the first thing we will do is to move the constant term from the left-hand side of the equation to the right-hand side of the equation so that it becomes -6. And so the new equation reads x squared plus 8x is equal to -6. Our next step is to consider the middle term, which is 8x. Then we consider the coefficient of the middle term, which is 8. We will find half of 8. Half of 8 will give us 4. We will square the answer to get 4 squared. Then we will add this to both sides of the equation so that the left-hand side becomes x squared plus 8x plus 4 squared. Then the right-hand side becomes -6 plus 4 squared, which is 16. Then on the left-hand side, we see x squared and we see 4 squared. So we bring both of them into a bracket and square. So we have x plus 4 into bracket and then we square it. So because we have squared it, it has taken care of the middle term 8x. Then we simplify the right-hand side, -6 plus 16, and we get 10. We now move the square from the left side to the right-hand side. So it becomes square root of 10 plus or minus. We finally make x the subject. So we move the 4 from the x from the left-hand side to the right-hand side. So it becomes -4 plus or minus root of 10. And so when you simplify this, you will see that x is -4 plus root 10, or x is -4 minus root 10. And this gives x to be -0.8377 or -7.1623. Let's look at the second question. 4x squared plus 8x plus 3 is equal to 0. The first question that we solve, the coefficient of x squared was 1. But this new question that we want to solve, the coefficient of x squared is not 1, but 4. So the first thing we do is to make the coefficient of x squared to be unity, to be 1. So we are going to divide through by the coefficient of x squared, which is 4. So we have 4 over 4x squared plus 8 over 4x plus 3 over 4 is equal to 0. We simplify that to get x squared plus 2x plus 3 over 4 is equal to 0. Then the constant term, we move it from the left-hand side to the right-hand side, and it reads x squared plus 2x is equal to -3 over 4. Then we take the middle term, which is 2x. We consider its coefficient, which is 2. We find half of it. It gives us 1. Then we square the 1 and add it to both sides of the equation. And so we will have x squared plus 2x plus 1 squared is equal to -3 over 4 plus 1 squared, which is 1. Then x squared, 1 squared, we bring it together into one bracket. And then we simplify the right-hand side. So into bracket x plus 1 all squared, it's equal to 1 out of 4. When we simplify the right-hand side, we get 1 out of 4. Then we find the square root of 1 out of 4, and that gives us plus or minus. Then we move 1 from the left-hand side to the right-hand side. So x is equal to -1 plus or minus 1 over 2. And that becomes x is equal to -0.5, or x is equal to -1.5. We want to look at a third method that can be used to solve quadratic equations. And that method is the quadratic formula. And it relies heavily on the method of completing the square. So we will use the method of completing the square to solve the equation ax squared plus bx plus c is equal to 0. And then we will derive the quadratic formula. And as we can see, the coefficient of x squared is not 1, it's a. So we will first divide through by a. Then we have a over ax squared plus b over ax plus c over a is equal to 0. This we simplify and it becomes x squared when we cancel a out. So x squared plus b over ax. And then we will move the constant term to the right and it becomes negative c over a. We consider the middle term, which is b over a. We find half of it. That gives us b over 2a. And then we square it and add it to both sides of the equation. So the equation becomes x squared plus b over ax plus into bracket b over 2a all squared is equal to negative c over a plus b over 2a into bracket all squared, which simplifies to become b squared over 4a squared. Then at the left hand side, the two terms that have squares, we bring them together into one bracket. So we have x plus b over 2a and we square it. And it is equal to the right hand side, which is b squared minus 4a squared minus ca. We continue this proof at the next stage. We maintain the left hand side as x plus b over 2a all squared in bracket. Then we find the LCM for the right hand side and we get b squared minus 4ac all over 4a squared. Then we find the square root. We move the square from the left hand side to the right hand side and it becomes square root plus or minus square root of b squared minus 4ac all over 4a squared. Then we simplify further. We have x plus b over 2a is equal to, at the numerator, the square root still remains, and then you have b squared minus 4ac under the square root. Then the denominator, you can find square root of 4 and square root of a squared. So you get 2a. Then you move the b over 2a from the left hand side to the right hand side by way of making x the subject. So x is equal to negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Then you find LCM of the right hand side. You have x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And this is what is called the quadratic formula, which can also be used to solve quadratic equations. Our next topic is quadratic graphs. A quadratic function may be defined as f of x is equal to a squared plus bx plus c. So we can draw the graph of such functions. We draw the graph by plotting ordered pairs such as x1, y1, x2, y2, x3, y3. And when you plot these ordered pairs, it will not give you a straight line like the linear function, but rather it gives you curves. The curve can be maximum curve or it can be minimum. The minimum curve opens upward, whilst the maximum curve opens downward. We will use example to simplify this. Example 10. Draw the graph of y is equal to x squared minus 6x plus 5 in the interval -2 less than or equal to x less than or equal to 8. Then B part of the question. Use your graph to find Roman number 1. The values of x for which the graph is alpha increasing, beta decreasing. Roman number 2. Equation of the axis of symmetry and the minimum value of the graph. Roman number 3. Solve the equations x squared minus 6x plus 5 is equal to 0. And the second one, x squared minus 6x plus 8 is equal to 0. We'll look at the solution at the next stage. Let's look at the solution. To look at the solution for this, we start by drawing a table of values for the function given. The first row of the table contains the x values for the interval given, which is from -2 to 8. The second row takes the first term in the function, which is x squared. Then the second term comes, -6x, and then the constant term, 5. The last row of the table takes the values of y. We simplify to get the values of y. So we start by putting in the first x value into x squared. So -2 squared will have 4. Then we move to the next x value, which is -1. -1 squared, it's 1. Then we put into it 0. So 0 squared is 0. We substitute 1 into it. 1 squared is 1. We move to 2. 2 squared is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. Then the next thing we do is to use the same values to multiply -6, because these values will replace x. So we have -6 times -2, we'll have 12. -6 times -1, we have 6. -6 times 0, we have 0. -6 times 1, we have -6. -6 times 2, we have -12. We continue with the x values till we get to the last one, which is -6 times 8, and that gives us -48. Then the constant term has no variable attached to it, so we repeat it. We then go on to find the values of y. So we add the numbers under -2, for example, 4, 12, 5, and we get 21. Then we add the numbers under -1, 1, 6, 5, we get 12. We add the numbers under 0, 0, 0, 5, we get 5. Then we add the numbers under 1, 1, -6, 5, we get 0. We add the numbers under 2, 4, -12, 5, we get -3. We add the numbers under 3, we get -4. We add the numbers under 4, we get -3. We add the numbers under 5, we get 0. We add the numbers under 6, we get 5. We add the numbers under 7, we get 12. And then finally, we add the numbers under 8 and we get 21. So the ordered pairs are going to be -2, 21, -1, 12, 0, 5, 1, 0, 2, -3, 3, -4, 4, -3, 5, 0, 6, 5, 7, 12, and 8, 21. That is a combination of row 1 and the last row to give us the ordered pairs. So after plotting the ordered pairs, we use a smooth line to join the points that have been plotted. And so this is the shape of the graph. It's a minimum graph because it opens upwards. You will see that it starts from the left and then it descends down to where you have x is equal to 3. Then from there, it starts increasing, going up to the last end. So this is the minimum curve for the function. We are to use the graph to answer some questions. The first one we are to answer is to find the values of x for which the graph is increasing. If you study the graph carefully, you will notice that from the point negative to 21, it starts decreasing and it decreases until it gets to the point 3 negative 4. That point 3 negative 4 becomes the turning point at which the graph turns and starts increasing. And it increases till it gets to the point 8, 21. So the point 3 negative 4 is the turning point. And beyond that, the graph starts increasing. So the values of x for which the graph increases is x greater than 3. Then the values of x for which the graph decreases are values which fit the inequality x less than 3. Then the next question is to find the equation of the axis of symmetry. We got the turning point to be 3 negative 4. If you draw a vertical line through that point, you will see that it will pass through the value x is equal to 3. And so on that vertical line, you can fold the graph into two equal parts. So that becomes the line of symmetry. And the equation of that line of symmetry is the x is equal to 3. And from the point which gives the minimum turning point, you can get the minimum value. And that is the value that corresponds with 3. And that is 4. So the minimum value of the graph is y is equal to 4. Then we move to the next question, where we are to solve x squared minus 6x plus 5 is equal to 0. So you draw this graph, you compare it to the original graph, and you will see that it is the same equation we use to draw the curve. And this intersects with the x-axis. And the x-axis is the same as y is equal to 0. And so the line y is equal to 0 and the curve intersects at x is equal to 1 and x is equal to 5. So the solution becomes x is equal to 1 and x is equal to 5. The second one, you compare it to the original equation that has been used to draw the graph. You notice that the first term is the same, the second term is the same. It's only the third term, which is the constant term, that differs. So you have to find a way of making them equal. In fact, the constant term in the equation that we use to draw the graph is 5, but the one we have to solve is 8. So if we want to make it equal, we subtract 3 from the 8. And so we will subtract 3 from both sides of the equation because you cannot subtract it from only the left-hand side. You must subtract it from both sides. And so when you do the subtraction, that equation becomes x squared minus 6x plus 5 is equal to negative 3. Then if you compare it again to the original equation, you notice that y now will be equal to negative 3 because y is equal to x squared minus 6x plus 5, and then negative 3 is equal to x squared minus 6x plus 5. So you can compare the left hand sides and say that y is equal to negative 3. Then we are going to draw the line y is equal to negative 3 through the graph. So we locate negative 3 on the graph and draw a horizontal line to pass through negative 3. This horizontal line will intersect with the original curve that we have drawn. Then we locate their points of intersection. And so these points of intersection, we notice that x will be 2 and x will be 4. And so we conclude that the solution to x squared minus 6x plus 8 is equal to 0 are x is equal to 2 and x is equal to 4. We want to look at types of quadratic roots. If you solve a quadratic equation, you are likely to get different types of roots. The kind of root you get, you can determine it using the discriminants before you even begin to solve. So let's look at the 3 types that you can get. Type 1, if the discriminant b squared minus 4ac is greater than 0, that means that if you simplify it and you get a positive number, then that kind of quadratic equation you are solving is going to have 2 different or 2 distinct roots. For example, you want to solve quadratic equation 3t squared plus t minus 10 is equal to 0. You want to know the kind of root you will get before you even begin to solve. So you use the discriminant bx squared minus 4ac. Our a is 3, which is the coefficient of t squared. Our b is 1, which is the coefficient of t. And our constant term c is negative 10. We substitute these values into the discriminant and simplify. You get 121. And 121 is greater than 0. This means that if you should solve the quadratic equation 3t squared plus t minus 10 is equal to 0, you are going to get 2 different answers, which we refer to as 2 distinct roots. In another form, if you put the values into the discriminant and the answer you get is 0, it means that that particular quadratic equation, if you solve it, you are going to get same roots, or you will get repeated roots. So for example, if you take x squared minus 6x plus 9 is equal to 0, a will be 1, b is negative 6, and c is 9. If you put it into the discriminant and you simplify, you get 0. So this means that if you should factorize that equation, x squared minus 6x plus 9 is equal to 0, you are going to get same values, what we call repeated values. Then the last one, if you substitute into the discriminant and you get a negative answer, that means that the answer you have is less than 0. Then it means that that equation will have imaginary roots. So for example, 5t squared plus 3t plus 9 is equal to 0. A is 5, B is 3, C is 9. If you put it into the discriminant and you simplify, you get negative 171. And this is less than 0. And so you cannot easily factorize it. If you do, you will get the what we call imaginary roots or complex roots. Let's look at symmetric properties of quadratic roots. And in these symmetric properties, we'll be looking at sum and product of roots. Quadratic equations are mostly represented by x squared minus into bracket sum of the roots times x plus product of the roots. So if we let the roots of the quadratic equation be alpha and beta, we will have x is equal to alpha and x is equal to beta. That means that x minus alpha will be equal to 0 and x minus beta will be equal to 0, giving us two factors, x minus alpha, x minus beta. We'll multiply these two factors, x minus beta, x minus alpha. And when we expand, we get x squared minus into bracket x plus alpha, which represents sum of the roots, then times x, plus alpha beta, which represents product of the roots. Let's look at an example. If the roots of the equation 3x squared minus 5x plus 2 is equal to 0 are alpha and beta, find the equation whose roots are 1, 1 over alpha, 1 over beta, 2, alpha squared, beta squared, 3, 1 over alpha plus beta, 1 over beta plus alpha. Let's look at the solution at the next stage. Let's consider the solution to the question. The equation is 3x squared minus 5x plus 2 is equal to 0. When we look at the equation we have considered, we had x squared minus sum of roots times x plus product of roots. So the coefficient of x was 1. So we will first divide through by 3 to make the coefficient of x 1. So that we will have x squared minus 5 over 3x plus 2 over 3. And we call this one equation 1. Then we have also seen that the product of the factors x minus beta, x minus alpha gives us x squared minus alpha plus beta, which is the sum, times x, and alpha beta, which is the product, is equal to 0. So we can call that one equation 2. Then we compare equation 1 and equation 2. Then we see that the sum, which is alpha plus beta, comes with negative. And in equation 1, you also have negative 5 over 3. So if the negatives cancel out, then alpha plus beta will be 5 over 3. Then the product alpha beta will be 2 over 3. Okay, so we now have the sum and the product of the roots. Now the roots whose equation we are to write is alpha, 1 over alpha, and 1 over beta. So we'll find the sum of 1 over alpha and 1 over beta. And we also find the product of 1 over alpha and 1 over beta. So the sum of 1 over alpha and 1 over beta, when you do the LCM for it, you get alpha plus beta over alpha beta. And if you put the values in place, alpha plus beta is 5 on 3 divided by alpha beta, which is 2 out of 3. And then when you simplify, you get 5 out of 2. Then when we take the product, we multiply 1 over alpha by 1 over beta. We get 1 over alpha beta. And that gives us 1 over 2 over 3, which when you simplify will give you 3 over 2. Now we will put the whole of this into equation 2. So we have x squared minus, so alpha plus beta, we got 5 out of 2. So we bring the 5 out of 2, then we multiply by x, then plus the product, which is 3 over 2. When we simplify, we get 2x squared minus 5x plus 3 is equal to 0. Looking at the second question, where we have to find the equation for alpha squared, beta squared. We have to find the sum of the roots and find the products of the roots. Then we use it to write the equation. So the sum of the roots is alpha squared plus beta squared. The expanded form of alpha squared plus beta squared is equal to, into bracket, alpha squared plus 2 alpha beta plus beta squared, then minus 2 alpha beta. Then what you have in the bracket is the same as bracket opens, alpha plus beta, bracket closed, squared. Then you bring minus 2 alpha beta. We already know the sum to be 5 out of 3. So alpha plus beta is replaced with 5 out of 3. And then you bring the square. Minus 2 alpha beta, which is the product. And we have gotten that to be 2 out of 3. We simplify and we get 13 out of 9. Then we come to the product. Alpha squared times beta squared can be written as alpha beta into bracket squared. And we know alpha beta to be 2 over 3. So 2 over 3 squared. And when you simplify, you get 4 out of 9. So we put these two answers into our equation 2. So x squared minus alpha plus beta is 13 out of 9x. Then plus alpha beta, which is 4 out of 9. You simplify this, you get 9x squared minus 13x plus 4 is equal to 0. That means we multiply through by 9 to get this answer. Let's look at the third solution. The roots are 1 over alpha plus beta and 1 over beta plus alpha. So we first find the sum by way of adding. So 1 over alpha plus beta plus 1 over beta plus alpha. Then we can bring beta plus alpha together, and then 1 over alpha plus 1 over beta also together, so that we find the LCM for 1 over alpha plus 1 over beta and simplify it, so that everything becomes alpha plus beta over alpha beta. Then we put the values in place. Alpha plus beta is 5 out of 3. Alpha plus beta again in the numerator, 5 out of 3. Then alpha times beta in the denominator, 3 out of 2. And when we simplify, we get 5 out of 3 plus 5 out of 2, which eventually gives us 25 out of 6. We again find the product, 1 over alpha plus beta in one bracket, multiplying 1 over beta plus alpha in another bracket. We expand to get 1 over alpha beta plus 2 plus alpha beta. We put the values in place. 1 over alpha beta becomes 3 over 2 because alpha beta is 2 over 3. So the reciprocal becomes 3 over 2. Then plus 2, and then plus 2 over 3, which gives us 25 out of 6. So the equation now becomes x squared minus 25 over 6x. 25 over 6 is the sum, then plus the product, which is 25 over 6. We multiply through by the LCM, which is 6, and we have 6x squared minus 25x plus 25 is equal to 0. You can try more examples on your own and show your solutions to your friends.